Here we have a function x times the absolute value of x plus 1 divided by x plus 1. So again, that same format where you have the absolute value being multiplied by the actual value x plus 1. So we're going to get some probably a discontinuity here, a jump discontinuity, because it's going to change based on the sign of x plus 1, whether or not that's positive or negative. We'll see that. So I want to evaluate the limit as x approaches minus 1. Limit as x approaches minus 1 of h of x is limit as x approaches minus 1 of x. Oops. X times the absolute value of x plus 1 over x plus 1. So that absolute value there, I want to rewrite it in a way that's algebraically equivalent without using an absolute value. So if I think about x, let's approach this from two different directions. So let's just approach from the left right now. If x is approaching minus 1 from the left, then that means x is less than minus 1. Right? There's x is equal to minus 1. And if we're approaching from the left, then x is somewhere here. So if x is less than minus 1, then x plus 1 is less than minus 1 plus 1, or 0. So x plus 1 is a negative number, which means that when I take the absolute value of x plus 1, it's going to be the same thing as negating it, right? Because it's already negative. So if I stick that negative right there, it turns it positive. So we can say that this is the limit as x approaches minus 1 from the left of x. The absolute value is just equal to minus x plus 1. We see that cancellation of x plus 1s now. This is just minus x. And via direct substitution, if I stick a minus 1 in for that x value, I get a minus minus 1, or a 1. From the graph, that makes sense. All right. Let's take the limit as x approaches minus 1 from the right. And we're going to do the same trick. If x is approaching minus 1 from the right, then that means I'm somewhere over here. So x is bigger than minus 1, meaning that x plus 1 is bigger than 0. So x plus 1 is already a positive number, which means that that absolute value is just going to return x plus 1, right? It's already positive. We get that cancellation. The limit as x approaches minus 1 of x returns a minus 1. That makes sense according to our graph. Right, that y value is minus 1. So the limit from the left-hand side is not equal to the limit from the right-hand side. Therefore, the limit as x approaches minus 1 of h of x does not exist.